Hello and welcome to Math 253, Calculus 3 here at Cañada College. My name is Lapuz. This is a video on one of the homework problems that we have in section 4.2, problem number 5. Here we have the limit as xy approaches 0, 0 of the ratio 1 minus cosine xy divided by xy or x squared y squared times 9 plus y. So in order to do this problem, what we're going to do is we're going to rely on one of the limit laws. And one of the limit laws states that if we have a product, a limit of a product, we can divide it up into the product of the limits if they exist. So that's our first step. Let's take the limit as xy approaches 0, 0 of 1 minus cosine xy divided by x squared y squared times the limit as xy approaches 0, 0 of 1 over 9 plus y. So if each of these limits exist, then we can just multiply them and get the product. So for the second one, I think the second one is pretty straightforward. What we could do is we could put in the 0 for x and 0 for y. We're going to get 1 divided by 9 plus 0. So that's just going to be 1/9. All right. Now this other one looks like if we put 0, 0 in, we're going to get the cosine of 0 times 0, so that's going to be 1. And then the zeros in the denominator would be zeros. Now, one thing that looks kind of suspicious here in a good way is that we can rewrite this as limit of xy approaches 0, 0 of 1 minus cosine of xy divided by xy quantity squared. So an idea here might be to consider off to the side, to consider maybe looking at the limit as some other variable u equal to 0 or approaches 0 of 1 minus cosine of u divided by u squared. Now, if I put 0 in here, cosine of 0 is 1, 1 minus 1 is 0, and this is 0 squared, which is 0. Now, we cannot use L'Hopital's rule when we're looking at functions of two variables and limits in a two-variable function sense. But we can use L'Hopital's rule here because we only have one variable u. So let's do that to get an idea what this limit might be. And according to L'Hopital's rule, this is a conditional equality because the limit eventually has to exist. Limit as u approaches 0, and we'll take the derivative of the numerator. Derivative of cosine is negative sign, but there's a negative here, so that would be a positive sign. And then this is 2u. Now this is still going to be 0 over 0 because the sine of 0 is 0. So we have another shot at L'Hopital's rule by taking the limit as u approaches 0, and we'll take the sine of u, which is going to be cosine of u, or the derivative of sine of u is cosine u, and this is just 2. So as u goes to 0, cosine of u will approach 1, and this is just a constant 2. So this is going to be 1/2. So because this limit is equal to 1/2, we can probably assume that this limit is also equal to 1/2. So by the work that we did with L'Hopital's rule, this is going to be 1/2. All right. Now we got that to be 1/2. We have this previous limit that we computed to be 1/9. So I think our total limit here will be just 1 over 18. All right. Okay, I hope that helps. Good luck.